Okay, dear students, in this video lecture, we shall discuss about the flux linkages due to external flux as well as flux linkages in parallel current carrying conductors. Okay, we'll discuss about the first thing, flux linkages due to external flux. You know the fact that whenever current flows through the conductor, then what will happen? A magnetic field is produced inside the conductor as well as outside the conductor. Whatever the flux that is produced inside the conductor, that links with the conductor, and we have already calculated what is the internal flux linking with the conductor. What are the internal flux linkages? Internal flux linkages. Flux linkages due to internal flux that we have already calculated. Now we shall calculate what is a flux which is flux linking or flux linkages due to external flux. So this flux which is produced externally due to the current flowing through the conductor, it extends from the surface of the conductor to the infinity. Okay, for we need to calculate, our objective is to calculate the inductance. Okay, if I want to calculate the inductance, then I need to calculate flux linkages first, because inductance is flux linkages per unit current, right? So we need to calculate the flux linkages. Okay, if we want to calculate the flux linkages, then we must calculate what is the flux density. If you want to calculate the flux density, then we have to calculate field intensity, right? So that we have to calculate what is the field intensity at this point, that is at a point x distance from the center of the conductor. This is your conductor and r is the radius of the conductor. Let us now see. Now let us calculate the flux linkages of conductor due to external flux. The external flux extends from the surface of the conductor to the infinity. The field intensity at a distance x meters from the center of the conductor outside the conductor is given by hx, which is equal to I by 2 pi x. I is the current flowing through the conductor. So I by 2 pi x ampere turns per meter length. So flux density Bx is equal to mu naught into Hx. Actually, it is mu into Hx. What is mu? Mu is mu naught into mu r. Mu naught is the absolute permeability and mu r is a relative permeability. Here I have taken mu r is equal to 1. So if mu r is 1, then Hx Bx, that is a flux density, is mu naught into Hx, which is equal to mu naught into I divided by 2 pi x Weber per meter square. Now, a small flux d phi through a cylindrical shell of thickness dx and axial length of 1 meter is given by, I have to calculate a small flux d phi for a small thickness dx for a unit length of 1 meter. So d phi is given by, this is a flux, d phi is calculated from with the help of flux density. So d phi is equal to bx into dx, area. Dx is area, right? So bx, substitute the value of bx. Bx is mu naught into I divided by 2 pi x into this dx will remain same. So Webers. What is the unit of flux? Webers. The flux d phi links all the current in the conductor once and only once. This flux links with the conductor once. And this flux linking with the conductor, there is a d lambda, small flux linkage. For a small area dx is d lambda, which is nothing but d phi, which is mu naught I divided by 2 pi x into dx Weber turns. What is this Weber turns? Flux linkage. Okay. Total flux linkages of the conductor from the surface to infinity. See, this flux linkage is whatever d lambda I have taken, calculated, it is only for this small area. If I want to calculate the total flux linkage, then I have to integrate from the surface to this area, that is, or infinity you can say. I have taken this because it extends to infinity. Therefore, you have to calculate from r to infinity. Okay, integrate. So total external flux linkages is given by integration of r to infinity mu naught I divided by 2 pi x into dx. Okay, this is the external flux linking with the conductor. So total overall flux linkages, which is linking with the conductor due to internal flux as well as external flux linkages, is given by lambda total is equal to lambda internal plus lambda external. What is this? Total flux linkages is equal to internal flux linkage plus external flux linkage. You know, we have calculated what is the internal flux linkage. That is mu naught into I divided by 8 pi plus external flux linkage integration of r to lambda, r to infinity mu naught into I divided by 2 pi x into dx. So I have taken mu naught into I divided by 2 pi common. So finally what I will get is mu naught into I divided by 2 pi 1 divided by 4 plus integration of r to infinity 1 by x into dx Weber turns per meter length. This is the overall flux linking with the conductor due to internal flux linkages as well as external flux linkages. Okay, so this is a flux linkages. Now we shall calculate the flux linkages in the parallel current carrying conductor. Okay, this is a group of parallel current carrying conductors. It means A, B, C, D, E, F. These are a group of current carrying conductors. A is also carrying current, B is also carrying current, C is also carrying current, D is also carrying current, E is also carrying current, and F also carries a current. D1, D2, D3, D4, D5 are the distances between conductor A with respect to other conductors. Like, you know, D1 is the distance between conductor A and conductor B. D2 is the distance between conductor A and C. D3 is the distance between conductor A and F. D4 is the distance between conductor A and conductor E. D5 is a distance between a conductor A and conductor B. So now we shall calculate what is the flux linkages in a parallel current carrying group of parallel current carrying conductors. Okay. So we'll consider only flux that are linking with the only one conductor. We'll take the example for calculation. We'll take the example of what are the flux linking with this conductor A only. Okay, the same procedure is applied to calculate the flux linking with other conductors also later on. Okay, but first we'll calculate what is the flux that is linking with this conductor A due to other due to the fluxes that is produced by the current flowing through other conductors. Okay, there will be flux linkages with conductor A due to its own current, as we have already discussed previously. Also, there will be flux linkages with this conductor due to the mutual inductance effects of IB, IC, ID, etc. If you remember, there are two types of flux, self-induced as well as mutually induced, right? If the flux linking with the conductor due to the current flowing through that conductor only, then that is called as a self-induced. Okay. If EMF is produced due to the flux linking with that conductor because of the current flowing through in the other conductor, then that's called as a mutually induced EMF, right? Similarly, so here also the same cases. We shall now determine total flux linkages with conductor A. Flux linkages with conductor A due to its own current, that internal flux linkage, as well as flux linkage, external flux linkage. Okay, internal due to its own current, I'm talking about. So mu naught into Ia divided by 2 pi into bracket 1 by 4 plus integration r to infinity dx by x. Just now we have calculated that. Now, flux linkages with conductor A due to current IB. Current IB, flux linkages with conductor A due to current that is flowing through this conductor IB. Current IB flows through conductor B. Flux linkages with conductor A due to current IB, which is given by mu naught into IB divided by 2 pi integration d1 to infinity dx by x. Call this equation number 2. I think you have understood this. The conductor B carrying current IB is at a distance d1 from the conductor A. Only the external flux due to IB links with the conductor A. This external flux due to IB links with conductor A from d1 to infinity, hence this equation. Okay. Similarly, flux linkages with conductor A due to current IC is given by mu naught IC divided by 2 pi integration. What is the distance between conductor A and conductor say d2, that is d2 to infinity dx by x. Call this equation number 3. Therefore, total flux linkages with conductor A is, and this will continue, okay, not only IC, you have ID, IE, IF, okay, the same will continue. Therefore, total flux linkages with conductor A is given by addition of all the equations. Equation 1 plus equation 2 plus equation 3, so on and so forth. So finally, if you substitute all these equations, so you will get what is the total flux linking with the conductor A. Similarly, we can also calculate the flux linkage with other conductors. This relation provides the basis for evaluating inductance of any circuit. This is our base equation. You should remember this properly. Okay, this gives the base for evaluating inductance of any circuit. Okay, in the next video lecture, we shall discuss about inductance of a single phase 2-wire line. Okay, thank you.